All right, welcome back to The Explainer. Today, we're putting on our hard hats and our dev hats. I want you to step into the shoes of an elite full-stack mobile architect and circular bioeconomy systems designer. We are diving deep into the blueprints of the 905 Wood Digital Refinery. And look, this isn't just a waste management system, it is an absolute masterclass in end-to-end systems design and edge AI. We're talking about taking a muddy, completely chaotic physical environment and forcing it into strict, audit-proof digital compliance. This right here, this is our core thesis. It literally drives every single design decision we make. We are building what we call a sentient bridge. Imagine taking the total physical chaos of a construction bin full of muddy 2x4s and transforming it into verified audit-proof purity that meets the incredibly strict demands of the global biocarbon market. Chaos in, verified purity out. Okay, let's pull up the blueprint. We're going to cover 1. Chaos to verified purity. 2. The Pixel 10 Edge AI stack. 3. RFQ and density engineering. 4. Multimodal triage and verification. 5. The White Protocol UI. And finally, compliance and liability management. Let's get right into it. Section 1. Chaos to verified purity. So, let's talk about the massive financial threat looming over us, the Ontario waste cliff, and how we literally engineer our way out of it. Because the economic scale of this problem is absolutely massive. Waste isn't just garbage anymore, right? It's a giant regulatory liability. With the upcoming CIRCL levy in Ontario, mixed waste gets slapped with a massive $60 a ton penalty. Ouch. But if we engineer a system to flawlessly isolate clean wood, boom, that exact same material transforms into a high-purity biocarbon feedstock asset that generates serious carbon revenue. We're basically turning a massive penalty into pure profit. Section 2, the Pixel 10 AI stack. To pull this off, we have to process some incredibly complex data in the harshest environments imaginable. You can't just run this from a cozy server room. Now, I know what you're thinking. A consumer phone? No way. But we are not treating this like a standard device. We're deploying a Google Pixel 10 Pro running Android 16 as a full-blown distributed edge inference server. By tapping into that Tensor G5 chip and its neural processing unit, this thing can run an 8-hour continuous duty cycle, baking in a hot truck cab without thermal throttling. It's a rugged industrial computer locked down by the Titan M2 secure element for hardware-level trust. And this number is everything. The sub-second rule. Out on a job site, you're usually staring at 0 bars of cell service, so our on-device AI has to intake and classify visual data in under 500 milliseconds, end-to-end, total dead zone. It's got to be blazing fast to keep those logistics moving. So how do we do that? We stack the light RT AI models very strategically right on the device. First up, Gemma 4 E2B handles that blazing fast sub-500 millisecond intake. Then, a larger E4B model steps in as a consensus guard, basically double-checking the math on risky stuff. And finally, we have a massive 26 billion parameter mixture of experts model running locally. It's essentially a pocket supercomputer, acting as a RAG engine to navigate crazy complex regulations without needing a single drop of Wi-Fi. Moving on to Section 3, RFQ and density engineering. Let's see how this all kicks off during the very first interaction with the customer. The second a customer requests a bin, the 95 Wood app instantly crunches the estimated weight using volume and density formulas. But here's the real genius part. It dynamically surfaces the massive spread between that $60 mixed waste levy and the $5 clean levy right on the screen. By slapping those headline savings directly on the quote, we are financially engineering the customer's behavior before a truck is even dispatched. Section 4, multimodal triage and verification. The bin is finally on site, and now we absolutely have to protect our entire system from contamination. We use a rigid escalation ladder based on the precautionary principle. If that first fast AI scan isn't 100% sure, it bumps it to the second model. If those two models can't agree with at least 85% confidence, that's it. Hard stop. The system rejects the load on ambiguity and kicks it over to physical XRF hub sensors, literal X-rays, to check the chemical makeup. We are picking safety over visual confidence every single time. And here is exactly why we have to be that cautious. We call it the visual fallacy. Picture this: weathered gray pine. To a camera, it looks like perfectly clean feedstock, but it's actually hiding toxic CCA treatment, arsenic. A camera alone can totally be fooled. But get this, If our Gemini Nano audio sensor hears the driver casually mention, say, a deck renovation, while scanning, the system registers the mismatch and instantly triggers a hard override. We literally have zero room for error here, because if our AI and the human operators both miss a bad load, and we breach these specific toxicity thresholds like arsenic over 2.5 milligrams per liter, we are talking massive regulatory exposure under Ontario Regulation 347. It triggers hazardous waste auto-manifesting. So yeah, in this architecture, safety always trumps speed. Section 5, the White Protocol UI. Truck cabs are noisy, highly stressful environments, so the interface has to be completely bulletproof to prevent operator errors. We call this the White Protocol. Think industrial minimalism, high contrast black, white, safety orange, and massive glove-friendly targets. But the coolest feature is how it uses an Android 16 OS level bypass. If there's a critical safety issue, like an overweight load, it punches right through the driver's Do Not Disturb settings. Meanwhile, it quietly batches all the normal notifications so the driver doesn't get overwhelmed. And when a driver confirms a load, there are no quick taps. They use a physical hold-to-seal mechanic. You press and hold for 2 full seconds, feeling this haptic lock fill up, kind of like pressing a heavy wax seal. In that exact fraction of a second, the Titan M2 chip grabs the hardware-level GPS, the timestamp, and the AI result, locking it into an encrypted kernel hash. Boom. A legally defensible, tamper-proof moment of truth captured right there in the mud. All right, final section, Section 6, Compliance and Liability Management. Let's see how all this raw, on-device edge data turns into actual revenue and bulletproof cloud compliance. All those locked-in classifications get securely pushed to Vertex AI pipelines up in Montreal. This is where Gemini 4.5 and AlloDeep do their magic to generate what we call explainable compliance, meaning the AI doesn't just give a simple pass or fail. It literally cites the exact Ontario Regulation 347 laws and codes for the provincial registry. It is completely audit-ready, right out of the box. And here's where the tech turns into serious cash. Think about the sheer genius of this decoupled billing model. The customer gets an invoice that clearly proves they avoided the $60 penalty and only paid the $5 clean levy. They save thousands. But because 905 would engineered that verified purity, they get to keep 100% of the $350 per ton carbon dividend. It's a massive win-win, backed up entirely by the data. Plus, since we use that Titan M2 chip to capture those encrypted hashes right at the bin, the system can instantly spit out a border-ready USMCA Shield PDF. This is a 9-point, hardware-attested certificate of origin. You hand that to customs, and it proves exactly where the wood came from and that it is flawlessly clean. No devastating transshipment penalties, just smooth sailing across the border. So, that leaves us with a pretty massive question. We just saw how off-the-shelf consumer hardware, supercharged with a rigorous edge AI architecture, can completely tame the absolute chaos of construction waste. So, how could you deploy this exact kind of elite mobile architecture to secure the chaotic physical supply chains in your own industry? Definitely something to think about. Anyway, thanks for tuning into The Explainer today, and I'll catch you on the next one.